Hello, today I have came up with another interesting problem, that is loan eligibility prediction. So before I go into details, so I just want to thank you for following and subscribing our channel. So you can consider this problem statement as a case study or a small project on machine learning. So once you have learned the fundamentals of machine learning, so consider this as a practice to enhance your skills. Here we have the problem statement, that is a loan eligibility prediction, and the problem statement is the company wants to automate the loan eligibility process based on the customer data filled through online forms, and the details of the data are these. That means that the data dictionary is this. So there is a loan ID which is unique, and then we have a gender. So we have column gender. So you can consider the gender column which has unique values, so male and female. And then we have one more column, married. The values of this as yes or no. Then the number of dependents, education details are there, and self-employed, yes or no. Applicant income, we also have co-applicant income. And then loan amount term, the credit history, good or bad. And then property area, which is having three unique values: urban, semi-urban, and rural. And our target variable is loan status. That means you need to make a decision whether the loan is to be approved or not. So as usual, we just import the required libraries at the beginning. So if you are not aware so which libraries are required, then you can also import them later. So here I'm importing NumPy, and to create an array, pandas are used to load the data and create a data frame. So we are using Matplotlib and Seaborn for data visualization. We need to split the data into train and test. So for that we are importing trains as split. And then this is an algorithm, random forest classifier. You can apply any classification algorithm. So I'm applying random forest classifier, and the model has to be evaluated. So for that the metrics are confusion matrix, classification report, recall score, and accuracy score. So once the libraries are imported, so we have been given with two files, train.csv and test.csv. You can find this data from Kaggle. So it is there, you can download the data from there and you can practice. And so loading the data, train.csv. Train is a user defined name, and also test, so loading both train and test data sets. Then I'm checking the shape of the data. Shape means the number of rows and number of columns. So we have 614 rows, 13 columns are there. Then info means information on your columns. Importantly, you can know what are the columns and what are the data types. And at the last you can also have the summary. So there are 4 columns which are of float 64-bit and integer 64-bit. One is there, which is applicant income, and then object type or 8. So as you know, no machine learning algorithms works with no object type of data. So you need to convert these 8 columns. And then I'm checking the shape of the data. So always one column is less in the test data set, that is target variable you cannot find, which has to be predicted. Then displaying the header part of the data. So you have this data set. So loan ID is there, gender, married, dependents, and at last you have the loan status. Even you can also check the test data set here. You can write test.head so to see the test data set. So you see there are missing values, as you can straightforward see. So no target variable in the test data set. Then having a descriptive statistics. So describe is the function of pandas which describes the data. So by default it describes numerical columns, which are applicant income, co-applicant income, loan amount, loan term, and credit history. You see the minimum applicant income is 150, right, and maximum is 81,000. The minimum loan amount is 9 as per the data, and this is as per the data only. And if you want to have a description of object type of data, then you need to supply the parameter which is include is equals to object. So these are all object type of data. So you can see, for example, married people, total count is 611, unique values are 2, s are no, and the top is s. That means the frequency for s is higher, so that's why top is s and the frequency is 398, like this. And in education, you have this one, unique values are 2, graduate, and I think ungraduate is there, right? The frequency of graduate is higher. Like this, you can also have a description of test data. Next, EDA is important when you do data analysis. So you need to understand the relationship between the target variable and other variables. So, and no algorithm learns from unique data. So that's why we want to drop loan ID from the train. Axis 1 means column. So this column is to be dropped. And then target variable is loan status. So checking the value count. You see S in the training data, S is 412 and no type is 192. That means the majority of the people have got the loan and the S is more. So this is also, we can say, imbalanced data. And then having a count plot using a Seaborn libraries, which shows the count of the unique values. So S type is more, as we have seen here, 412, 22, and no type is 100, 192. Then gender, so most people are male type, the frequency is higher, 489. For the same, you are having a count plot to see graphically. The females are less, the number is 112. Then relationship between the gender and loan status here, so having a count plot, and you see male majority is male and the S type is more. Also even female, the frequency is less and S type is also more. And relation between married and loan status, so you can see married has two unique values, no and S. So most people are married, and you see, and also their frequency is also higher, because you can see graphically majority people have got loan. Okay, S is no, most, and then N is small. Then loan amount, so like this you can explore other variables, loan amount, and we are having a distribution plot from Seaborn which shows the histogram and also the combination of KD plot. You see there is a skewness actually in this one, so the slope is towards the no, right side, so positive skew or right skew is there. And then the facet grid is one of the important visualization type provided by Seaborn, and we want to see the relationship between this gender, married, and then mapping with the applicant income. Also legend is added, so this shows the applicant income gender wise and also married. So here male, married no means not married, and see the income is higher. Okay, income is in the range of this, right? And male and S, so married people are having higher income, you can see over here, than not married. And here female and no means females and not married, the income is less, and here also the female and married, the income is also less. So we are comparing three things: gender, married, and applicant income. Then there is one interesting plot, that is paid plot, which shows the distribution of all the columns which are of numeric type, and comparing the variables with the target variable loan status. So this quite takes a couple of seconds because it has to make the analysis of all the variables. So you can see if the variable is of same type, you can just have it a distribution plot here, and you can see the other variables. S no, this here is the legend. No, S is represented with blue and N is orange color. You see the values over here, the relations between all the variables, and applicant income, co-applicant income, loan amount term, loan, and also loan amount and credit history. So like this you can go for data exploration. You can also try other graphs by using matplotlib and seaborn. And next, importantly, we are checking the missing values in train. As you can see the numbers here, there are missing values in gender as well. Gender 13 means 13 rows are having missing values. Similarly, we have missing values in married, dependents, self-employed, loan amount sorry for the then loan amount term. Credit history has many missing values, and the count here 0 means no missing values. Number means these many missing values are there. Similarly, I'm checking the missing values in test as well. So in test also we have the missing values. So next immediate thing is we need to impute. Okay, we need to impute. Here I can just give a brief. If the data type is numeric, then you have two options, mean and median. You need to check for the skewness. If there is a skewness, then you have to apply median. If there is no skewness, you have to apply mean. And if the column or variable is of object type or categorical type, then only one option is mode. So for gender we are applying mode, and dependence is categorical type, so mode. Married is also mode, and self-employed mode. Credit history, all these are object types, so we are applying mode, means frequency. Based on the frequency the value is assigned. Then on credit history applying mean, understand? So on the credit history you can apply mean or median based on the skewness. If you want, you can also check the credit history value distribution plot of credit history. Let us check over here, distribution plot. Let's do this. Or else you can also write the data frame name, not just, you can check the skewness also, because there is a predefined function skewness over here. So train of the column name is credit history dot skew. So there is negative skew, so you better apply median. So instead of mean we can go with median. If there is skewness, apply median, because it adjusts the data to the middle, right? So this is done. And loan amount time, there is a skewness also. Loan amount and loan amount is numeric, so applying median. Also you can check on the loan amount. I think we have already checked at the top, so there is a skewness in the loan amount, so applying median. And for loan amount term, so it's object type, so imputing with mode. Then as I mentioned at the beginning, so no algorithm works with object type of data, so you need to convert them. So we are importing label encoder from scikit-learn.preprocessing. Then these are the columns which we want to convert. Then creating object to the class label encoder. And for column in feature column, so applying the label encoder both on train and test. Here also you can make a note, we are applying the same thing both on train and test, because the test data is used. So similarity should be there. So now encoding is done, and I'm also converting the target variable s with y with 1 and no with 0. And then I would like to add applicant income and co-applicant income, then assigning it to the variable total column is created, and then also dropping the columns applicant income and co-applicant income. Then we can see the sample columns here. So the total income is created after loan status, and we don't have applicant income and co-applicant income, and you see all these variables are numeric type. Then listing the columns, and then so from here you directly copy these columns and put into the variable relevant features. I want to create a relevant features, then finding the correlation between the loan status with other variables, then displaying these values. So see, the correlation, higher correlation value is the credit history, so 0.54. Next higher is which one, this married people, right? Also gender is affecting 0.01. Minus means negative correlation, doesn't affect. So one increases, the other one decreases. Positive means one variable increases, the other one decreases. So like this. The same thing can also be visualized by using the heat map. So having a heat map here, as you can see, the relation between the target variable and other variables. So this color means higher correlation, and the dark blue means negative correlation. So that is about the heat map. Next is building the models. So I just want to drop loan status from the train, and the remaining all variables are assigned to X, and Y is the target variable loan status. So data is separated. Then we want to split the data into train and test. So I am splitting the data into train and test. The test size is 0.3. So you can make it 60/40 also, 70/30, or 80/20, or 90/10 also. So even 50/50 also. Specifying the random state here 7. You can do parameter tuning, and based on the results you can stick with the parameters values, otherwise you can change the values. So data is separated. So the first model I would like to build is a random forest. So with 100 decision trees, the maximum features are selected based on square root. Then fitting the data. So model learns from train data always. Then making the prediction for X test, so which is 30%. The result is assigned to RF predict. Then evaluating the model with the confusion matrix. So here you can see 30 samples are correctly classified into 0 class, and 31 are misclassified. In 117, so 7 misclassifications are there. The accuracy over here is 79%. If you round it up, it will be 80%. And for classification algorithms or models, we need to check the recall score. In case of 1, the recall score is good. Even precision is F1 score is also good for class 1, whereas for 0 it's 49%, because this data is imbalanced. Then also applying one more algorithm, logistic regression. I hope you guys are having the fundamentals of machine learning, so that is why I'm not going in detail. So I'm not explaining each and every step in details, because the prerequisite is you should have the fundamentals of Python and machine learning. You should be knowing how the models are built. So importing logistic regression, and then creating object, then fitting data, then making the prediction for X test, then evaluating the model. So here also 31 misclassification into 0 class, and 7 misclassification into 1 class, and the accuracy also same 0.79, 79%. So if you round it up, same 80%. And then building one more model, gradient boosting classifier, same 100, the estimators are 100, the maximum depth is 5, right? And we are doing the parameters tuning here. Minimum sample split at 2, learning rate is 0.1. with this, fitting the data, making the prediction, and displaying the values. So the accuracy is decreased here, 0.075% only. If you, let's say, change the learning rate here, so it is increased, so approximately 82%. So learning rate is placing an important role here. And what about recall score? Here 98% and 48%. So this one is 94/49. In terms of recall score, you have to consider. So 4994, 4994, these are same, and here 4890 and 88. So this is also good, but we need to consider the recall score and F1 score. So F1 score is the harmonic mean of precision and recall. So recall means correct predictions. So like this we build three models, and next you have to submit the results. So we have been given with the test data set, and the shape of that is, we have already checked, that is no 367 rows, 12 columns. We need to make the prediction for all these rows, and we have to submit. So in the result submission, only decision should be there. So who's the, what is the loan ID, and then the decision, yes or no. Loan needs to be approved or not. So here I'm submitting the results by using random forest. So making the prediction for test data for the relevant features, and creating a data frame. In the test, in the data frame, only two things: what is the loan ID, and then the status. The loan status is predicted, right, predicted value by using the model. Again we are converting the s and s with 1 and no with 0, and in the data set we just have two columns, loan ID and status, then saving the results. So this file is going to be created. Index false means we don't want to save the index. Then the file is saved, and then submission.head. So you just want to see how the data looks in submission. So loan ID is there and loan status is there. You can also check the value count. So S type is 288, and no is, the count for no is 79. So like this you can submit the results to your boss or to the higher person with the decisions on your data. And whenever you do the data analysis, finally you have to conclude. So what conclusions you have drawn. For example, here I have listed, so you can just get it later on. What I'm trying to say is you have to conclude with the decisions. So as we have seen with the figures, the male people are having a higher frequency, and also they are having more income compared to the females. And applicants who are male and or graduated have more applicant income over the applicants who have not graduated. So by looking at the data and data exploration, you have to you have to list out the findings from your analysis. I hope this will help you to have a practice, or to practice your machine learning skills. And I show you the process, how the data analysis is done, and then how to submit the results. So thanks for watching, and do subscribe our channel, and you can also reach out to us for more queries and more doubts. Do comment also if you are having any queries on this particular problem statement.